In the last video, we had introduced Laplace transformation, what Laplace transforms are. We had also seen Laplace transformation of certain elementary functions like Laplace transform of unity, Laplace transform of t to the power n, Laplace transform of sine at, cos at, and so on. In this video, we will discuss the properties of Laplace transformation. There are basically three properties of Laplace transformation that we will be discussing. First is called the linearity property, second is the first shifting property, and third is the change of scale property. So let's start with the first, linearity property. Linearity property. What is linearity property? Let's say we have three constants a, b, c, and we have three functions a, b, c are constants, and f, g, and h, these are three functions of t. Then according to linearity property, Laplace transform of a f t plus minus b g t plus or minus c h t. This can be written as a Laplace transform of f t plus minus b Laplace transform of g t and then c Laplace transform of h t. This is why L is also called a linear operator, or not called L is a linear operator because linearity principle can be applied. So this is linearity property. We'll prove this. Why do we need proof? Because if you prove properties and theorems, you'll understand the basic approach of solving problems. Let's see. Laplace transform of a g t. What is this? This will be 0 to infinity e to the power minus st, and this is a g t dt. So if this is like this plus b, let the first function be f. So this will be a f t plus b g t plus c h t. So this will become 0 to infinity this plus b g t plus c h t dt. We can take it out. We know that linearity principle applies in integration. So this will become, we will take this part first. So a is constant, it will come out. This will be 0 to infinity e to the power minus st f t dt. Then plus or minus whatever we have, 0 to infinity, b is out, so this will be e to the power minus st gt dt. Similarly, okay, what is this? This is a into Laplace transform of f t, this is b into Laplace transform of gt, and this is c into Laplace transform of ht. So this can be written as Laplace transform of f t, then we have b into Laplace transform of gt, c into Laplace transform of ht. This is what we had stated. So we have proved this property. How do we apply it? Very simply, very simple. For example, if we have to take Laplace transform of, let's say, Laplace transform of sin 80 plus cos 80, just this will be equal to Laplace transform of, or let's complicate it further, twice sin 80 plus 3 cos 80. So this will be twice Laplace transform of sin 80 plus thrice Laplace transform of cos 80. What is this? This is twice, this is a by s square plus a square. This is thrice s by s square plus a square. So this can be written as 2a plus 3s s square plus a square. This is linearity property. So I hope it's clear. The second property is called the first shifting property. It is when we multiply a function by e to the power at. So I'm writing here first shifting property. What is it? If we have Laplace transform of ft is fs, if we are denoting it like that, then Laplace transform of e to the power at into ft is given by the function of s minus a. This is first shifting property, very important property. Let's prove it. Let's prove this property. We have Laplace transform of at into ft given by 0 to infinity e to the power minus st into e to the power at ft dt. Clear? No issues with this? This can be written as 0 to infinity e to the power minus s minus a into t ft dt. So this is the function of s minus a. If you want to go to the very elementary level, I would say, let's say we s minus a is m, then 0 to infinity e to the power minus mt ft dt. What this will be? Function of m, because we had this when minus st it was function of s, so this is function of m. And what is m? Function is s minus a, m is equal to s minus a. Therefore L into e to the power at ft, we get function of s minus a. This is a very useful property. Let's see what it means. Just now we saw, let's start with Laplace transform of 1. It was 1 by s. So what is Laplace transform of e to the power at? That is e to the power at into 1. This will be 1 by s minus a by first shifting property. Similarly, Laplace transform of sin 80, we had just seen it was a by s square plus a square. So what will be Laplace transform of e to the power at into sin 80? It will be a by s minus a square plus a square. Simple. Similarly, we can have the values for other functions also when we multiply it by with e to the power at. This is the first shifting property. Finally, the third property is called change of scale property. Change of scale. What it says? It says if Laplace transform of ft is fs, then Laplace transform of at, if this is the function, this will be equal to 1 by a function of s by a. This is the third property, which is change of scale property. Let's prove it. Let's see the Laplace transform of FAT. What it will be? 0 to infinity e to the power minus st, then this is function of at dt. What do we do? Let m be equal to at, then dm is equal to a dt. Let's put it here. 0 to infinity s. S is what? Okay, no, sorry. T is what? M by a. So this will be e to the power minus s m by a. And this is f of m. Dt is dm by a. I am taking 1 by a out. So now what is this? If you compare with the original equation, this is now s by a is now s and 1 by a is out of it. So this will be 1 by a function of s by a. This is the property that we were just discussing. So we have proved it. So we saw three different properties of Laplace transformation: the linearity property, the first shifting property, and the change of scale property. Now we will see some questions, we will see certain problems, and we'll try to solve them using these three properties. Our first example is, it's say if Laplace transform of sin t by t is tan inverse 1 by s. It says then find Laplace transform of sin at by t. This is our question. We have sin t by t. Laplace transformation of sin t by t is equal to tan inverse 1 by s. Then it says find the Laplace transform of sin at by t. What we will do? We have to find the value of Laplace transform of sin at by t. So what we do? We multiply it with a. This will now become sin at by at. The third property that we just saw, the change of scale property, it says if we have function of at, it will become 1 by a function of s by a. So this value will become 1 by a into function of s by a. Here we had s, so this will be now s by a. A cancel, so this is equal to tan inverse a by s. We got the answer, very simple. Now we'll be using the first and second property to solve another problem. Let's say we have a function of t which is e to the power minus 4t into 3 cos 3t minus 4 cos 5t, sorry, instead of cos, let's use sine. Sine 5t. We have to take the Laplace transform of this function. So Laplace transform of this function ft, by first property, this is linear, so this can be taken separately. These two terms can be taken separately. So this will be 3 Laplace transform of e to the power minus 4t into cos 3t minus 4 into Laplace transform of e to the power minus 4t into sine 5t. No problem. What is the Laplace transform of cos 3t? Cos 3t, we have s by s square plus 3 square, that is 9. But we have this. So what we'll do, instead of s, this will be s minus a, that is s plus 4. This is minus 4, a is minus 4. So this will become 3 into s plus 4 by s plus 4 square plus 9. This is the first part. Second part is 4 into sine 5t is, we have 5 here, and then s plus 4 plus 25. Now you can multiply and you can resolve everything and you will get value. So this is how we take the Laplace transformation of a function where we need to apply both the theorem, both the properties of Laplace transform. There is a very beautiful question. It says find the Laplace transform of t cos at and Laplace transform of t sin at. What we do? If you remember, e to the power at is given by cos at plus I into sin at. Okay. So what we do, if we multiply it with t, we will get this thing. So we take the Laplace transform of e to the power at into t. By our first shifting property, the Laplace transform of t is 1 by s square. So this will become 1 by s minus ia square. Okay. How can we resolve it? By multiplying by s plus I a square. If we multiply the numerator and the denominator by s plus I a square, what will happen? This will be s square minus this square. This square is I square a square. I square is minus 1. So this will be s square plus a square whole square. Now let's break it. This is s square plus this square. I square is minus 1. So this will be minus a square plus I into twice as by s square plus a square. So the real and imaginary parts can be separated. This is s square minus a square by s square plus a square whole square plus I 2as s square plus a square whole square. So this is the real part. If we take Laplace transform of this, this is Laplace transform of this and this. So separating the real and imaginary part, Laplace transform of t cos at is this, and Laplace transform of t sin at is this. So I'm writing it properly. Laplace transform of, where to write it? Okay. Laplace transform of t cos at is given by this thing. This is equal to s square minus a square by s square plus a square whole square. And the second part, Laplace transform of t sine at, this will be the imaginary part, which is equal to twice as by s square plus a square whole square. So transformation of a function of t into function of s by Laplace transformation is very easy. As you can see, we are applying only 3 properties and we are getting the transformation. Later on we will see some other properties. We will learn how to transform periodic functions, and there are other concepts also. So for the time being, work on this, be very comfortable with this, solve at least 10-12 examples from your textbook, and then in the next video we'll move ahead. Thank you.